and really a nice surprise for me to stand up here and see the room is almost full. So congratulations, Olive. You not only entertained the early starters, but you also encouraged others to come in through your presentation. Olive will be around for the day. Yeah, so there's obviously a lot there, and there's probably a lot of questions. So I think across the day, really search out Olive. It's a good opportunity to talk through what he's done, understand how it might be applied in your part of the world. We're going to jump now to the other end of the power system. Tree is going to come up and talk to us about what's going on in the world of A1. I won't steal his thunder by telling you what A1 is. I'll let him do that. And there will be a pop quiz at the end of the day where we see who can remember which code corresponds to which study committee and what they're all about. Tree, over to you.
Thank you, Dave, and good morning, ladies and gentlemen. Thank you, Olive, for giving us a lighted presentation. I didn't realize, amazing what you do with the stuff that we generate at the beginning. That's what A1 is all about. I'm Tran. I work for AGL, and I'm A1 panel convener for Australia. We are all about rotating machines, generators, motors, and the like. We're only responsible from the coupling drive to the terminal box. After that, we hand it over to the other 15 conveners. I know nothing about the other stuff. Our purpose is we focus on the development of new technology and international excellence, exchange of information, knowledge, and future rotating machines. Add values to information, knowledge, and synthesizing state-of-the-art practices and developing guidelines and recommendations. So pretty simple purpose. Rotating machine is what we're interested in. We have 4 advisory groups. Start from the top, we have turbo generators, which the majority of the power is generated. They are large, and they got larger problems. We look at a range of things, condition assessment, maintenance, refurbishment, power upgrade, asset management, and long-term asset assessment for those plants. Now, in Australia, we have a large fleet of aged plants, and that's a major problem for us, for the industry. And another spectrum is we don't really want to spend the money. So somehow we need to manage the old stuff without spending a lot of money. The advisory groups are very active in this area. The second group is the hydro generators. It's basically the same thing except geometry different, construction different, and different mechanical problems, so it's electrical problem. So we do talk to one another. And we learn from each other, and basically we turn the machine 90 degrees and we get the other one. The third advisory group is non-conventional rotating machines, and they are coming to the scene in large numbers. Wind generators. We don't have a lot of superconducting machines yet. It's still in early stage at this point, but we focus on the wind machines. They're small, but they come in large number. Imagine they have one single problem and it's cascades through a few thousands. And then it costs a lot of money if we have a problem at the beginning. And of course, they have quite significant impact on the grid, and the grid has a significant impact on them. And if they don't talk to one another, we have a fallout of network supply. And the last advisory group is large motors and drives. Can't run the power station without them. We focus on larger motors, 1 kV and above, and 500 kilowatt and above. Some of the machines, as you already know, could be 10 megawatts or above, depends on what we drive. In the power station, typically we can get to about 8 to 10 megawatt motors, and they do have their own problems. Then we have variable speed drive, and we look at the benefit of efficiency motors, variable speed drive, and the impact of operations of motors. Now, I like to pay a little bit attention on that last few words. It is very important because the network has changed, the operations of the large power station have changed. We used to run them as base load, now we run them up and down all the time because the wind farm over here going up and down with the wind, and down here we go in reverse direction. And then what happens to our generators, our motors? They go up and down the same, and they're not designed to do that. Therefore, they have mechanical problems that breaks. And when they break, we're down. So it's an important issue we're looking at. The key areas of interest: asset management, extended life of existing generators, or recommended their replacement, as I mentioned that before. Machine monitoring, diagnosis, and prognosis of performance, optimal maintenance. We do monitor these machines quite tightly, similar way you monitor your network in different way. Renewable generation, which may be connected directly to the transmission, distribution, or directly to the customer in the case of microgrid. Yes, I mentioned the renewable generation before. They come in large number, and they come in weird locations away from the load. So therefore, we have a fairly swing of voltage and so on. So it's quite a complex issue. And then to add salt to the wound, this machine being small, being large number, being low cost, we have low cost associated problems. And already come to the service, so a lot of machines fail within few years in service, and they all do the same thing. So what do we do with them? When to factor in the economic equation to these machines, they're not as low cost as we think they are. And that's one of our challenges. Well, how do we make them better without spending a lot of money or increasing the cost so much? That's another challenge for us. So we got some smart people looking into that. Enhancements in the construction of a large turbo generator and hydro generators. Construction-wise, they complicated. We tried to simulate them, to monitor them, to design them. It's if you're not interested in mechanical engineering, and would you want to do these things, you can face some challenge because the end winding, for example, their dynamics is amazing while they're in service, and if we're not careful, they'll shake themselves to pieces before we know. So the construction is so important. They can't be too tight, they can't be too loose. Efficiency of rotating electrical machines with new materials involving cooling and insulation system with generators and motors. Now this we work with G1 quite closely. There's a lot of technology coming on the scene, which we can make the machine better with better materials. Large motor and high efficiency motors, as mentioned before, they come to different technology. Every technology has their own problem. The VPI system, for example, vacuum pressure impregnation, do have problem because not everybody got it right. And then we end up with an afterward problem once the machine is running. And then we went to rewind them or something, we can't make them the same. And of course, the last interest is the utilization of polymer nanocomposite is a near future for HV electrical insulation rotating machines. In my world, it's a new horizon. The major activity this year for our panel is a colloquium and tutorial in India, last September from 22nd to 28th. Quickly running through that. The working group session presentations is basically from the working group, we have a range of working groups. Some of them still active now, some of them working, and some of them about to start. Of course, we had other working groups in the past, and we had technical portion and so on and so forth, as you're aware of. So these are the current one. We have 4 working groups that finish. For example, the working group 39, they look at the testing for conductor bars. 3 working groups at the final stage, and 3 new working groups, and the latest working group 66 is a joint working group where A1 and C4 joint force looking at synchronous condenser, which is a flavor of this decade because of, again, the renewables, and then we need more synchronous condensers in the system. The chairman gave us a briefing and a summary on meeting activities, the membership status, and women in CIGRE, e-CIGRE, and KMS, and so on. And the proposal of 2021 colloquium in Japan and 23 in Russia. 4 tutorials were presented on magnetic core dimension limits in hydro generators, application of dielectrics dissipation factor measurement on new stator cores and bars, that's working group 39. And then we have guidance on requirement for the requirement on high speed balancing over speed, testing of turbine generator rotors, following maintenance and or repair. It's quite an important subject, and in particular in Australia, we only have one place who can high-speed balance our rotor, and that's in Geelong, owned by ABB. The technology is quite amazing. You spin this thing 3,000 RPM, you only allow a tiny amount of vibration. They don't like weight in the wrong place very much. So we look at the guidelines, and I think it's a very interesting one, very useful one. Guide for cleanliness and proper storage of generators and components. Again, it's a very useful one for us, and we look at quite details. A lot of people left a lot of things in generators similar to transformers, and they do cause a lot of grief. I spent 19 days, 24 hours a day looking at for a ball that big because someone left in generator. And then the colloquium talk on 2 preferential subjects. High renewable penetrated network, again the wind farm and the renewable we talked earlier. Operational experience of new development. We had 24 presentations on large turbo generators and hydro generators, machine installation system, and large motors. And then at the end, or one at the end and one at the beginning, there were 2 technical tours, one at the power station and one at the HVDC terminal station. Relevant to Australia, so on hydro and turbo generators, recently we completed the process 690, vibration and stability problems, met in new and old refurbished hydro generators, root cause and consequences. I was fortunate to go into some of these, and it's amazing mechanical structure inside. It's more mechanical device than electrical. The electrical bit is very small. So yeah, some of the hydro machine, we can't take the rotor out because of it to do with the turbine downstairs, which I don't really want to know, but I'm worried about the coupling upward. And we found that being so large in diameter and so heavy, they behave very differently and different range of speed. So that's important to us that we look into those things. Working group 29, we have a new generator, grid connection requirements, highly relevant to prevention of widespread state blackout, blah, blah, blah. You know about this one, so I don't need to mention this. As I mentioned earlier, when the wind or when the renewable generation don't talk to the main generation network, and we had something in between to fall over, then we have chaos. Working group 31, talk about state of wiring support system. As I mentioned earlier, an ongoing problem, and we don't seem to get everything bed down in the industry. So we're working on that, and yeah, we get a few new techniques. 37, working group 37, generate state wiring support system, experience. Don't let them anywhere near 100 hertz vibration. They shake themselves to pieces. I've found some of them, and once you see this brown fretting dust around the end winding, that's when you're going to have some problems. So again, we are about to prevent those things. I mentioned earlier, old machines, these things happen quite regularly. New networking group, proposed guide to synchronous condenser. This new working group is really exciting. We got AEMO involved as well. I represented our panel. We got a new panel member, and yeah, it's quite an interesting one to work with. Thank you for your attention. That's all I have today.